Here is a definition. The composite function f composed with g is defined to be f composed with g of x is equal to or equivalent to f of g of x. Okay? Now, a few things about this. This is a small open circle. It's not the letter O. This is not spelled like fog, okay? This is a small little open circle, and it means composition. It's an operation. I'm going to show you what it looks like right now. It does not mean multiplication, okay? This is not multiplication. So f composed with g of x is f of g of x. Now, let's look at an example to show what this means. All right, check out this example. I've given you a linear function named f. It is 5x plus 2. Another linear function named g, and it is 2x minus 1. Okay? The first thing we're going to find is f composed with g of 3. F composed with g of 3. So 3 is like your x value right here. So we're going to rewrite this like this right-hand side here. Okay? So this, by definition, means, here, if I can write it, like this. F of g of 3. Okay, everybody? So I just rewrote it using the definition. This is the definition. Now, what this notation means is you want to plug, now listen carefully, this is the whole idea. You're going to want to evaluate g at 3 first. Plug 3 into g first. Find out what that number is, what that output is, and then plug that output into function f. One more time. Plug 3 into g, figure out what that function value is, take that function value, and then plug it into f. This is not simply plugging 3 into g and then taking 3 and plugging into f. No, you plug 3 into g, figure out what that is, that result you plug into f. All right, so let's see if we can figure this out. So this is going to be equal to, now let's figure out g of 3, okay? We're going to be plugging 3 into g, basically right there. 2 times 3 minus 1. 2 times 3 minus 1. That's me plugging 3 into g, all right? Let's figure out what that result is. So this is f of 2 times 3 is 6. 6 minus 1 is 5. Not negative 5, positive 5. 5. So now I take this result, which is 5, this function value, and I plug it into f, okay? So I'll have, now plugging 5 in for the variable in function f is right there. So 5 times 5 plus 2, okay? So 5 times 5 plus 2. 5 times 5, of course, is 25, plus 2 is 27. This is the final answer. This is the function value. Remember, 3 was your input, 27 is your output. Of course, also called your function value. All right, let's try something else. Now they want us to find g composed with f at -2. This is a great place to pause the video and see if you can try this on your own, okay? G composed with f at -2 is going to be g of f of -2. Okay, so this time around, you're going to plug -2 in as your input into function f. You're going to figure out what this is, right? You're going to find this function value first. This function value you'll plug into g. All right, let's go. So then this is g of, now I'm going to plug -2 in right there for f, okay? So it'll be 5 times -2 plus 2, like that. All right, let's figure out what this is. 5 times -2 is -10, and -10 plus 2 is -8. So now I take -8 and plug that into function g, which is over here. So it'll be 2 times -8, then -1, like this, right? So our final answer then is going to be, what is this? -16 minus 1, -17. This is our function value, okay? Input, output. Now, we're almost done here. You have to understand that the first two examples were finding function values, right? You were finding an output for a corresponding input. This time around, they're asking you to find a function. Find the function you get when you take f and compose it with g. All right, so let me show you how this is different. So this, by definition, is f of g of x, like that. So what this means is you're going to take g of x and you're going to plug this expression into f, right? G of x is 2x minus 1. That's what g of x is. G of x is 2x minus 1. So you're going to take this expression, which represents g of x, and you're going to take this expression and plug it into f as your input. So this is function f. I'm replacing this variable with the expression 2x minus 1. So it's going to be 5 times 2x minus 1 plus 2. Just like this, right? 5 times 2x minus 1, this is g, and then plus 2. Now, all you have to do at this point is simplify. Okay, you're not solving anything, right? You're not solving. You're just simplifying by distributing the 5. So you get 10x minus 5 plus 2. So you get 10x minus 3. That's as far as you can go as far as simplification. And this is a linear function, right? It's a linear function. So when you compose f with g, this linear function with this linear function, you get another linear function, which is 10x minus 3. You have to understand there's nothing more to do. You just found a composite function, right? So in part A and B, you are finding a function value. But here in part C, you're finding a function. Now to wrap this up, let's compose g with f. You may be thinking, well, didn't we just do that? No, we just composed f with g, and now we switch the order of composition. And composition is not commutative. That means that if you change the order in which you compose two functions, your result will be different, right? And so we expect to get a different function here. Now, I invite you to pause this video and to give this a shot on your own. All right, so I hope you paused it, and let me show you what the composite function is. G of f of x. Now that's by definition. So then this is g of, now f of x is 5x plus 2, right? I've even color-coded this for you. So this is f of x. I'm taking this expression, plugging it into g. Basically taking this expression, plugging it into that variable right there. All right, so here we go. So it's going to be 2 times 5x plus 2, right? And then minus 1. Okay, now all you have to do here, don't do more than you should, all you have to do is simplify. So what we're getting here as a final result is 10x plus 4 minus 1. So we're getting 10x plus 3, okay? This is another linear function, okay? A linear function.